Hello all. In this particular video, we'll be learning about the concept of synchronous up counter with JK flip-flop. So the aim of the experiment is to design and implement a modern which is n is equal to 8 synchronous up counter and demonstrate its working. You need to understand what is the difference between synchronous and asynchronous counter. So synchronous counter means, so there is a common clock which has been connected to all the flip-flops which is present over here. We call this as a synchronous counter. Asynchronous counter in which you'll be having a separate clock pulse for each of the flip-flop. This is the first thing. The prerequisite for this experiment is you need to have prior knowledge of what is flip-flop and its type and the working principle of JK flip-flop. See, in my theory part, that is the playlist of analog and digital electronics theory, we have uploaded the video of the flip-flops. Please go through the video in which I have explained how to derive the truth table of a JK flip-flop, from which we'll be writing the excitation table, and also we'll be writing our characteristic table. Coming to this experiment, so the IC which we use here is 7476 IC. This is your synchronous up counter mod 8 IC. So the pin configuration goes like this. See, it is a 16 pin IC. So in 16 pin, since it is, we have two clock pulse, that is 1 and 6th act as clock pulse. Second pin and 7th pin acts as preset input. Third and 8th pin acts as your clear input. And then we have 5th pin for power supply. Next we have 15 and 14. 15 and 11th pin for Q1 and Q2. 4 and 16 for J1 and K1. 13th pin is ground. 16th pin is 12th pin is K2. 9th and 10th is J2 and Q2 bar. 11th pin is Q2. So this is the pin diagram of your 7476 IC. Before we start this experiment, we need to write the truth table and excitation table of your JK flip-flop. In my previous video, we have demonstrated how to write your truth table and excitation table for your JK flip-flop. Truth table of JK flip-flop is, if J input is 0 and K input is 0, my next state is Qn. So here Qn plus 1, Qn is my present state, Qn plus 1 is my next state. So if it is 0, 1, it is 0. If it is 1, 0, it is 1. If my J input is 1 and K input is 1, it is Qn bar. Qn bar is also called as toggle state. It means that there is a fluctuation of 0 to 1 and 1 to 0. We'll be learning more about toggle state when we start demonstrating this particular experiment. Excitation table of JK flip-flop is, for 0, 0, Qn is my present state, Qn plus 1 is my next state. What is my value for J and K? For 0, 0, your J and K is 0, don't care. If my previous input is 0, next state is 1, my JK value is 1, don't care. If it is 1, 0, it is don't care 1. If it is 1, 1, it is don't care 0. To know more about this excitation table, you need to understand the characteristic table, and then you can understand very clearly how this excitation table came. Please go through my previous videos of flip-flops in which I have explained you the concept of the truth table, characteristic table and excitation table. So now using your excitation table, I'll be drawing the state diagram for your flip-flop. So here we have written the present state, next state, what is the value of j and k for these present and next state. For example, so my present state is, since it is mod 8 counter, that is from 0 to 7, the flip-flop will be able to count the numbers from 0 to 7. Here I have written from 0 to 7, that is 0, 0, 0 till 1, 1, 1. My next state, here when you are writing, what is the next state of 0? After 0 it is 1, 2, 3, 4, 5, 6, 7. So what is the next state of 7? It is 0. After this part, we'll be writing what is the value of j and k for your present state and next state. From the excitation table, as you can see, if my qn is 0, qn plus 1 is 0, my jk value is 0, don't care. Coming to this, see here, now we'll take only q0. My present state is q0, my next state is q0 bar or q0 plus. If it is 0, 1, what is my j0 and k0 value? So for q0, your j0 and k0. For q1, it is j1 and k1. For q2, it is j2 and k2. Now, observe only your q0 value. It is 0, 1. What's the value associated with 0, 1? For 0, 1, it is 1, don't care. So it is 1, don't care. Next. Second, I have 1, 0. For 1, 0, I have don't care 1, don't care 1. So similarly, I will apply my excitation table. So here to determine all the values of j and k for q0, q1 and q2. After writing this, the next step is plotting the k-map for each of these things. For k0, j0, k1, j1, k2 and j2. If I plot the k-map, my k0, I am having these values. So k0, I am having these values. If I plot these values, the answer which I have got for k0 is 1. j0 is 1. j1 is q0. k1 is q0. j2 is q0, q1. And then k2 is q0, q1. I hope so you have understood how to plot the k-map for each value. So let's say we have k0, it is don't care 1, don't care 1. So here I have written don't care 1, don't care 1. Next it is don't care 1, don't care 1. So this is how you fill the values, and of course you know how to plot the k-map. So after writing this, how many values which we have? Here we have almost 1, 2, 3, 4, 5 and 6. So to plot all the 6, we require 3 flip-flops. So as you could see here, I have 3 flip-flops. One is for J0 K0, J1 K1 and J2 K2. See, for J0 and K0, my Q0 and Q0 bar is my present and next state. For J1 K1, Q1 and Q1 bar is my present and next state. For J2 K2, Q2 and Q2 bar is my present and next state. This is the first thing. Second thing, so here we have the output Q0, here we have the output Q1, here we have the output Q2. Let's start the connection now. What is my answer for K0? I have K0 is equal to 1. So here you'll be going for K0. It is 1. K0, and you please observe the answer for J0 also. So J0 is also 1. So I will be shorting J0 with K0. I'll be connecting it to plus 5 volts. Next, J1 I am having Q0, K1 I am having Q0. So I will be shorting your J1 and K1, and then I'll be connecting it to Q0. So here I am having Q0. So this is where I can connect it to Q0. Next, J2 I am having Q0 Q1, K2 I am having Q0 Q1. First I will take the product. So Q0 and Q1 I'll put it in an AND gate. So the output I'll be connecting it to J2 and K2. So after connecting this, we need to write the pin numbers for all these things. So here, as we could see in the pin diagram, first input is 4th and 16th pin. Next is 9th and 12th. Again, we have 4th and 16th pin. After writing this, if you do the proper connection with your digital trainer kit, your mod 8 counter is ready. So that your counter starts working and start counts from 0 to 7 and again from 0 to 7. This is all about your synchronous up counter with JK flip flop. Thank you.